let's look at vectors as ordered set of numbers. Now, in graphs, we have seen x and y coordinates, and we have seen that a point on this graph or on the plane is represented as x comma y, right? Where depending on the context, they belong to a particular field, right? Either if we are interested only in integers, then it will, the x and y will belong to integers. If we are interested in real numbers, real numbers. So depending on that. Okay. Now the order of writing is important here. Yes. So 3 comma 2 is different from 2 comma 3 since they represent different points on the coordinate plane. Okay. Now similarly, we use x comma y comma z to represent a point in 3 dimensions or 3-dimensional space. Now, in case of vectors, we again use ordered pairs, ordered set of numbers to represent them in the appropriate dimensional graph, P or 3D, or higher dimensions mathematically or analytically, more appropriate. Okay? So, for example, v is equal to 3, 4, 5, u 6, 7, 8. So this is a vector with 3 numbers. Okay. So p is equal to 1, q could be say 2, 1. So here, remember, these are position vectors with respect to the origin, and this is called a ordered 3 tuple. This is a ordered 2 tuple. Now a tuple, or more appropriately a n tuple, means a set containing n numbers with fixed positions. So basically what this means is that if I'm using the word tuple, I don't have to use the word ordered, because the tuple itself means that it is an ordered set. Okay, so now let's say, for example, x is equal to x1 comma x2 and so on up to xn. This is a n tuple and x is called a n vector. So here you would have say 1 comma 2 comma 3 is a 3 vector. 3 comma 2 comma 4 comma 6 is a 4 vector. Each element in the n vector is called component of the n vector. A vector may be written as a row matrix or as a column matrix. In a m by n matrix, each row will be a n vector. So that means there will be m rows representing n vectors. Now, a vector whose components are all 0 is called a 0 vector, and we represent it as a O. Okay, so as you might have noticed, matrices can be used to represent vectors. So which means the algebra of vectors would be quite similar. So in the next session, we will look at algebra of vectors. That's it for now. Bye.